Okay, I think it's about time. Good afternoon. Welcome to this discussion. It's about containers in embedded. So just to manage expectations, it's really meant as discussions. I'm not really, I mean, I'm working in the embedded world, but I'm not a field expert now in containers. So it's really meant to kind of open discuss issues around containers and embedded. So I work for a company called Toradex, and we do ARM computer modules like this one. So these are modules with an SoC on it, with memory on it, and flash usually, and we sell them in high volumes to various customers. And we built also software for those. That's where I come in. So I'm an embedded software engineer. I'm in the BSP team, so in the board support package. Work mostly on U-boot and kernel ports for our modules, but also on the open embedded part for our BSP. And we recently started to build kind of a new platform for our modules, which is based on the Linux microPlatform software stack, which is from Foundries.io. Yeah, and now I would like to hear something about you. Who of you, I was just wondering, so how many of you already used containers? I guess most probably, like on the desktop or on the, okay. Yeah. And then on the embedded device, yeah, how many did you use on the embedded device? Also quite some, a bit less. And how many did actually deploy like a product using containers in practice? Okay, interesting. Yeah. So just from a high level, I mean, where are the advantage? From my point of view, it's this high level of abstraction, and that you can rather easily distribute the whole application. It's the lightweight compartmentalization, so just that you have the option to limit the amount of resources allocated to a container or to an application. It has, of course, also security benefits, but compared to virtual machines, it's not as heavy. So that kind of makes it really nicely applicable to embedded space, right? We don't have resources, too much resources, so having a kind of lightweight solution there is nice. Yeah, and then interoperable applications so that you can just run applications on various embedded platforms. That's really a huge advantage. The whole embedded field is still rather, yeah, there are rather different boards and different software stacks, and having kind of a higher level abstraction makes it easier to distribute the applications across different kind of boards. And it's independently updatable. Then, yeah, there are different container runtimes. So some of them are OCI runtime or follow the OCI runtime specification. That's Docker nowadays with Runc and Rocket, for instance. But there are also runtimes which are not following standards or have their own kind of format, systemd nspan or LXC, LXD. There is kind of a little bit difference between a system versus an application container. So containers where you basically run an init system inside the container, and where the container kind of boots a complete operating system with all its services, or containers which basically just have the one application running in it and still rely on services from like the outside host system. Yeah, and then container images. So getting to container images is also different kind of ways to get it. When Docker has this kind of full spectrum, full world with a Docker hub, so you have the Docker client to then download the images directly. What I see with Docker a little bit problematic, although there is some security or there is optional security to containers or for containers, by default if you get an image from Docker Hub, it's not checksummed, or it's not, well, it's probably checksummed, but it's not signed, so it's, yeah. And then there's also might be licensing issues, so when you think about deploying an embedded product which has a container which comes from the from Docker Hub, you usually don't really know what kind of binaries are in there and how did those binary got built and what is the license of all that. That's kind of a, yeah, it's rather dangerous actually to get to ship something which you might not really know what you actually ship. And yeah, you can, I mean, if you don't have Docker or if you have like just systemd enspandy, then you just have a root file system tarball which you obtained somewhere. And of course you can, so if you use Linux distributions, that they often come from Docker Hub, right? But if you use like Open Embedded, you of course can also cross-compile the container using Open Embedded, which then gives you again the full control and you have licensing compliance and everything, these tools. But yeah, it's not as easy, right? You kind of need to learn Open Embedded, have that steep curve, learning curve there. Yeah, and then one step further, so if customers use, so since we actually sell not an end product, our customers usually develop on our platform, right? So what we then, what we need to kind of figure out, how is the development story for our customers? So how are they supposed to use containers on our embedded system to build an application? And there is also kind of different ways how you could go about it. So if you use inside the container, if you use a distribution inside the container, you could also install the build utilities in the container and kind of do all inside the container and natively. Or you could use, there's a technique to run ARM containers on x86 via emulation. So you would then use QEMU and user mode emulation to then basically run the same container on your faster x86 machine, and still do native compilation. Or again, the open embedded way that you basically just cross-compile everything, including maybe an SDK, and yeah, get build applications also using Open Embedded or the SDK from Open Embedded. And then when building applications, there are also ideas that IDEs or build tools get more aware of the container, so that, for instance, your whole build make files inside the IDE or whatever your build system is, kind of knows that there are containers and deploys applications directly to containers or into containers and push it maybe to something like a Docker registry. Yeah, so that are kind of high-level thoughts from my side. Now I really would like to invite, I don't know, ideas, thoughts about all that. Maybe someone.
So I think you hit a really big point that everybody in the embedded space maybe, or just really in the container space has glanced over, is licensing. And so I'm curious what your thoughts are, and maybe anybody in this room. So VM images, cloud images, typically the way those worked with licensing is that the distributions providing them if you basically had an unmodified cloud init image from a distribution, that they would be, Fedora or Canonical would provide the source code on your behalf. Does anybody know if that's true with containers? And is anybody aware of a licensing agreement with the distribution for using their distribution in a container? I guess that would be the question. I think that's something we're going to need to figure out and get some sort of precedent set.
Yeah, it's maybe really something which legal also should look into. I mean, the question, I guess, in cloud, it's often the container stays inside the company, right, kind of. So you're not really, you don't need to, I guess, you don't need to provide sources for that. So, yeah.
No, I think there is a distribution there, right? So licenses usually trigger in when you are a distributor. So in this case, you are changing the distributor from a cloud. So who is kind of like, providing all that license? Because when you are getting it from cloud, either whoever created the image is the distributor, or
Right.
is Docker the distributor, or?
Yeah, I mean, yeah, when you build your, I see what you're saying. So when you just get your Docker base image, who built that and who is then responsible to provide the sources for that? Yeah.
Well, going to the lawyer talk yesterday, I'm not a lawyer. But ultimately, who's providing you the binary is Docker, is not the person that built it, right? And so, in theory, Docker is the one that, given that they're providing you the binary to the executable that's GPL v2 licensed, I would think that it's their responsibility to make available the sources to you if you take the GPL v2 license to that.
So what we've done, when we build base images, based on distributions, we store the tarball off to the side and have that as a build artifact so that if customers, say we need the source code, we have it available. But it's actually kind of hard because you actually just need to tar up what you build in that moment, because distributions are constantly changing. So it's like a snapshot of the distribution at a time, which is kind of worthless to most people. But for license compliance, you need to do those things.
But then you only have the binaries, right? You don't have the sources to.
Well, so I do the tarball import, right, to create your own base layer.
Ah.
Yeah, when we started doing the micro-platform stuff, none of the base layers, like the distributions, were providing like ARM-based images, right? And so we decided we were going to build them all, and so we had to look into how they were doing it. So you basically, like with Debian, right, you bootstrap a CH root and you tar it up, and then you do a Docker import. So when we do the bootstrap, right, I mean, where's that source coming from, right? It's coming from all the apt mirrors, and so we're kind of like, we can save the tarball of the root file system we use, but that's not the source code, right? And so we're kind of at a loss on how we basically get the distribution like Debian to say, yeah, you're distributing source on our behalf, and that's okay because it's the same. And I don't think there's any way for them to do that right now. It's kind of an open question.
I guess the Debian package manager knows which sources those packages have been built for, right? So as soon as you kind of know what kind of binary packages and the exact versions you have, you probably can really get,
all of the source.
Yeah, all of the source.
Leaving the licensing aside, you need tooling that can do that mapping.
Yeah, I agree.
You can basically have a manifest or something that basically you can ship. That people can
Yeah.
sources or somewhere.
Well, I guess that for distributions, this tooling or all that should be there from distributions, right? Where I also feel it gets even more trickier then is if people use a Docker file to do some additional stuff on top of a distribution, which is maybe kind of binary only, or there are sometimes layers, for instance, to integrate binary drivers for graphics stack, for instance, and then it also gets a bit more tricky.
Yeah, the Google Assistant demo we did for the keynote on Monday, that's a binary blob that Google provides for some of the speech recognition. So again, you're not able to redistribute that container because you're getting a binary redistribution from Google, and that brings in a whole other angle. But yeah, I think we need to solve out how we deal with the base images and then how we deal with derivative images off of that. It's an interesting problem.
Yeah, definitely. Yeah.
So I think one of the issues that I see in application containers is generally there is no provisioning, easy provisioning interface. So for example, the applications, they open ports, they open sockets, and all those kind of resource access they need. So it's all like manual, in the sense that you are tweaking that, creating that first template, but then that's not scalable across multiple applications. Each application you have to containerize for once. You have to spend effort on doing that. So I wonder if there is some tooling that you can say scan the application and say, hey, it tends to use these ports, or maybe some sort of like output that it can tell that it expects these kind of ports to be open, or that
Good
kind of stuff.
questions. I guess the kind of in the server world, the container orchestration solves that to some degree, but I'm not sure in whether they have kind of standardized templates for that.
Right. That's what I was
Yeah.
hoping that.
Yeah, I don't know.
Well, I mean, they have the expose directive inside the Docker file. So you expose, and so when you just run it without any port arguments, it picks up, oh, you want me to open these ports, and it's from the Docker files where it's getting that. So
but that's kind of Docker specific,
exactly,
right?
and it's still not a scalable
Yeah.
thing because you have to define that in the Docker file. One thing we've done is run in the net host context, which runs in the same IP context as the host. And so as services bind, they just, the ports are open because they're running on a local host. But that's a little dodgy because if you don't have a firewall set up and you're opening ports and this thing's connected to the internet externally, then you can open ports you didn't intend to. Whereas if you do port mapping, it's usually just on a bridge network unless you've got a firewall in front. So you have to be aware of what you're doing when you do those things.
So what I see is that a good use case is there is an app that we can containerize, give people tools to containerize their app while they don't know containers. Right, so they have an app, now you want to run it on your platform, and you say, hey, containerize it. Then either you do it or they do it. But then if there is tooling that you can provide them, saying, hey, here is a tooling that will basically give you a basic template, looking at your app, these you can run. Okay, it will find out you need to open these ports, so here is sort of your template, or then they can provide that information, right?
Yeah, well, I guess with Docker and Docker files, that's kind of given. I mean, you would probably make a Docker file as a template and use Docker. But that's a bit the question we also have. We were also thinking about using different Docker runtimes or container runtimes than Docker because, well, Docker in the end, I mean, it's not super lightweight, and I don't know. I think, so using Docker has definitely huge advantages. There's a ton of documentation out there, and issues like this are kind of solved, right? But then I also rather feel that at least when the device is really kind of restricted in like flash size and all that, it might be also worth to look at like more lightweight kind of containerization applications. But, yeah.
So the other area is like, how do you assign resources to them on resource-constrained systems? Because now you got container that has a JavaScript in there, right, which launches in a browser, and it can kind of, ask as much memory as it wants. So now you want to say you only have 80 meg, that is assigned to you. How do you define those? So basically all those are things that would make it, if there is some tooling available to do that partitioning and all those things clearly, like sometimes you might download a container on the fly and you know what your system is available right now, right? And then you can say, oh, I can't run this container because there is information in the metadata which says I need 1 gig and you don't have 1 gig on the box. So so while you are provisioning it, you can give a good error message to the user saying that, sorry, I can't run it. Right now, there is, these are kind of like the errors. I don't know if somebody has solved those. I would be interested to know.
Well, you can assign resources to a particular container, at least with Docker, but I'm not actually sure that it errors in a good way if you say, give it this much memory and I don't actually have it. I'd have to try that.
Yeah.
Right. That's a good, important point, and especially too, I like your idea of being able to understand, say, I'm asking to provision this device, do I have enough resources? And even before anything starts to happen. Yeah.
Yes.
Yeah, I mean, container orchestration is a problem that I don't think is solved yet for the embedded space. I mean, I personally think Kubernetes or something like that's a little too heavy-handed to be running on the edge, but maybe there's cases where you'd want a scalable, like dynamic web service to run across multiple nodes, and maybe that makes sense. But what we're kind of struggling with is, how do we deploy workloads in a reasonable way? And a lot of times I think the problem is not just deploying the containers itself, but the files. Like you need to bind mount in to configure the different things that you're running, like Nginx or something like that. You need Nginx configuration. So how do you deliver not only the container definition, the port definition, but also the files that need to be that's specific to the configuration on your device, and how does it scale? I think that's a problem that we're looking to solve, but we don't really have an answer right now.
Yeah, I guess, usually those bind mounts, are from the host system, right? So on the host system, I guess you anyway have some configuration which you kind of need to manage. I guess ideally they should be kind of managed similarly. Well, okay, one are more system specific, the others more application specific. So yeah, I can see.
So one example of that is for our edge gateways, right? When we're joining Bluetooth devices, you want to create a whitelist. So your gateway only talks to these 10 devices. So you have to encode the MAC addresses in a file for a Bluetooth joiner container, and that's a system-specific, environment-specific thing that needs to happen. So the way we've solved that, well, not solved it, but we've checked in the Docker Compose file into a Git repo along with the other configuration file, so at least it's under source control. And then we have a little container daemon that monitors Docker Hub for changes and Git changes for those images, and we'll pull like new images down and redeploy the Docker stack on Git pushes or Docker Hub pushes. And it works, but it's still like, the scaling part. If you needed to manage 1,000 devices like that, it doesn't really scale very well, so.
Yeah, so yeah, I was really kind of hoping that with Kubernetes or something like that, it should be solved. But yeah, there's probably really the question of whether that scales down to edge devices. I'm not sure, has Kubernetes high kind of requirements on the kind of client side? I mean,
yeah, it's up to 2 gigabytes the moment you launch it without doing it for edge device.
Yeah.
okay. So, but that's not.
Yeah, right.
But Docker Compose also allows to kind of really do like swarm, like like centrally kind of manage all those containers.
Yeah, within an entity, so within a physical host.
Okay. Within one host. Okay. Yeah. But then across host, and I guess that's where Kubernetes also has features that you kind of can scale that to your whole like deployment of devices, right? Ideally, you would want that for embedded use case, that you kind of manage all your devices somehow to deploy new applications or updates.
I mean, yeah, and that's where you're going to hit the limitations of current embedded devices, right? If you look at the stuff that EdgeX Foundry is doing, they've taken an approach of write whatever you want on your container and run however many containers you want. But I mean, this is founded by Dell, and they want to sell servers with 1 terabyte of RAM in them to be your edge device, right, at $50,000 a pop or whatever. So I don't, like, the concept's really good, but it's just not feasible for what the majority of the edge devices is going to be, right? Where, to me, a simple thing that they haven't really spent any time trying to solve is just that the containers is very easy for you to use whatever you want as the underlying baseline, right? And you can have half of them be on Debian 8, a third of them be on Debian 7, 2 on Debian 9, all versions of Ubuntu, and then all of a sudden you pull in 50 containers and they all have underlying baselines that are completely incompatible. And these things are, the final result is something absurd when you say, well, no, just, stick to these 3 versions as the underlying.
Well, I guess, or the way I see it for our customers, often those devices are rather simple. They don't have, they are not super multi-purpose. They have a single purpose kind of. So you usually know you run 1 or 2 applications maybe on those embedded devices. So I guess that's kind of handleable in embedded devices.
Yeah, but even if you're running a small amount, if you want to open up to third parties, right, where you want to say,
okay.
I want to bring in 2 or 3 vendors that are doing these, and you don't restrict and say, by the way, use Ubuntu 18.4 as your baseline, or Alpine as would be more appropriate for an embedded. This version of Alpine. as soon as you bring 2 or 3, they're all very tiny in isolation, but you start putting 4 or 5 of these, and
Yeah.
you know,
Yeah, and this-
Mongo and
yeah.
I think we like the container management, like,
Mm.
delete one, bring on one, like how Mac is doing, right? I feel I don't know, the way basically dump out your application and then download it from the Mac and start it to run.
yeah,
Yeah.
leave it on the cloud and bring it in on demand. Well, yeah, I think the smaller ones, it is a fixed set of units that, yes, you know, you want to make sure that it works, but to just say, well, it's not going to fit, sorry, is also not going to be a great thing, right? Whereas one of your vendors decided to jump versions and didn't tell you about it. Next thing you know, your aggregate number. Because that's the whole thing, is it's very opaque to you until you install these 3 Dockers in a session side by side. You don't know what their aggregate number is going to be, whether it's going to be, you know, the size of 1 plus 10% of 2 and 3, or size of 1 plus size of 2 plus size of 3
Yeah.
individually. And to me, that's a big.
So I think that's if you can encode that in application
Yeah.
and then have some tooling to aggregate that. It won't be accurate, but if you can
Yeah, at least it gives you a notion that, you know, this is just not going to work, right?
Yeah, I think time is pretty much up. So yeah, if you have thoughts, ideas, or question or whatever, hit me on somewhere on the hallway. And have a good afternoon.